Rsa Algorithm. RSA is a public key crypto system that is widely used for secure data transmission. It is also one of the oldest. The acronym RSA comes from the surnames of Ron Rivest, Adi Shamir, and Leonard Adelman, who publicly prescribed the algorithm in 1977. The security of RSA is based on the fact that it is easy to calculate the product n of two large primes P and Q. However, it is very difficult to determine only from the product and the two primes that yield the product. This composition is also called the factorization of n. As a starting point for RSA, choose two primes P and Q. First prime is 11 and second prime Q is 13. From the algorithm to work, the two primes must be different. Public key. The product n is also called modulus in the RSA method. N equals P times Q equals 143 for 8-bit. For demonstration, we start with the small primes to make the factorization difficult. The primes must be much larger. Currently, values of n with several thousand binary digits are used for secure communication. The public key consists of the modulus n and an exponent e. E is equals to 23. This e may even be preselected and the same for all the participants. Secret key. RSA uses the Euler function of n to calculate the secret key. This is defined as Euler n and P minus 1 equals Q minus 1 is equals to 120. The prerequisite here is the P and Q are different. Otherwise, the Euler function would be calculated differently. It is important for RSA that the value of the Euler function is comprime to E. The largest common divisor must be 1. GCD E Euler n equals 1. To determine the value of Euler n, it is not enough to know n. Only with the knowledge of P and Q, we can efficiently determine Euler n. The secret key is also consists of A, D with the property that E times D minus 1 is a multiple of Euler n. Expressed in formulas that following must E times D is equals 1 mod Euler n. In this case, the mod expression means equality with regard to a residual class. It is x times y mod z. If and only if there is an integer of a with x minus y equals z times a. For the chosen values of P, Q, and E, we get D as D is equals to 47. This D we can always be determined if E was chosen with the restriction prescribed above. For example, with the extended Euclidean algorithm. Encryption and decryption. Internally, these methods works only with numbers which are between 0 and n-1. A message M is encrypted with the public key and E by calculating M equals M raised to E mod n. Decrypting with the private key N D is done analogously with M equals M raised to D mod n. This is M equals M raised to D x M equals M raised to E times D mod n. RSA exploits the property that x raised to A equals x raised to B mod n. If A equals to be modular and as E and D were chosen appropriately, it is M equals M. The order does not matter. You could also first raise a message with the private key and then power up the result with the public key. This is what you use with RSA signatures. Messages. In the following, two text boxes, plain text, and ciphertext, you can see how encryption and decryption work for concrete inputs. Plain text enter numbers. Examples 613 111 is 7. Ciphertext enter numbers. Example for 128 52 and 67 is 2.